Hello students, welcome to the next lecture on conventional manufacturing processes, and in this lecture we will discuss in detail about capstan and turret lathe and the turret indexing mechanism. So to understand the capstan and turret lathe, you must need to be familiarized with the basic parts of the lathe machine. And we know that the basic parts of the lathe machine are headstock, then tailstock, next is saddle, carriage, bed, tool post, and the tool. So we know that a basic lathe machine has all these different parts. So now what is the variation from standard lathe machine to this capstan and turret lathe? Now the first and foremost variation is that in capstan and turret lathe, one can use more than one tool for the machining purpose. That means multiple number of tools can be used for the purpose of the machining. So that is the first and foremost advantage. Second, that is the in capstan and turret lathe, the turret indexing mechanism is useful to provide automatic changing in the tool based on the requirement. And here the tool movement is also different compared to that of the standard tailstock available in the standard lathe machine. So we will understand in detail the difference between this capstan and turret lathe. So first of all, let us see over here. You can see the similarity in capstan lathe. These are the basic requirement. These two as the headstock, then the tool post, next is cross slide, then feed rod, then bed is available, right? It is required for the supporting of all the attachments that are available in the lathe machine. Then it has the saddle. Now here the major difference that is both has the hex turret, that is the hexagonal turret to hold more than one cutting tool. And here one major difference available between this capstan and turret lathe, that is the in capstan lathe auxiliary slide is available, whereas in turret lathe no auxiliary slide is available. So these are the difference according to the parts available in the capstan and turret lathe. So now as you can see, in the case of this capstan lathe, this hexagonal turret is supported by this auxiliary slide, and this auxiliary slide, or many times it is known as the ram, it is supported on the saddle. That means hex turret is provided on the ram and this ram is provided on the saddle, and this auxiliary slide, this particular component or ram can slide over the saddle in forward and backward direction. That means the movement of the tool is provided by movement of the auxiliary slide. Whereas in the case of the turret lathe, as you can see, this hexagonal turret is rigidly fixed on the saddle. That means here for the movement of the tool towards the workpiece or away from the workpiece, the movement of the saddle is required. So here the saddle movement helps to move the tool according to the requirement. Similarly, in the case of the capstan lathe, movement of the tool is carried out by the reciprocating or to and fro motion of the ram or the auxiliary slide. So this is the basic difference between the main important components and their movements available in the capstan and turret lathe. So now we will see in detail the difference between these capstan and turret lathe, which is the very important topic to understand. So now let us see the first difference indicated over here. As we have seen in capstan lathe, the turret tool is mounted over the ram, right? And this ram is mounted over the saddle. We have seen this, as you can see over here. this hexagonal turret is mounted over the ram and this ram is mounted over the saddle. Similarly, in the case of turret lathe, this turret head or the turret tool head is mounted over the saddle like a single unit. Now here this hexagonal turret is mounted over the saddle as a single unit. Now here we have seen that for providing the movement of the tool, the ram movement is required. Whereas for providing the feed of the tool or the movement of the tool, here the saddle movement is required, right? That we have also seen. Next, this turret head cannot be moved in the lateral direction of the bed. That means in capstan lathe, this turret head can move in only to and fro direction. It cannot move in either or lateral direction. Whereas in the case of this turret lathe, in the case of this turret lathe, this turret head can move in the crosswise direction. This means it can move in the linear direction also and it can move on the lateral direction also. Now to hold the workpiece in the capstan lathe, mostly the collet is used. Whereas to hold the workpiece in the turret lathe, mostly power jaw chuck are used. Now in capstan lathe, as the moving parts are available which are non-rigid, that's why the heavy cuts on the workpiece are not possible. Whereas in the turret lathe, the tool is available on the rigid part and it is and no other movements or reciprocating movements are available, and that means heavy cuts can be easily given on the turret lathe. Now next one is that is the as there is no saddle movement, the movement of the turret tool head over the longitudinal direction of the bed is small along with the ram. So what it means is, as you can see over here, saddle movement is restricted, means saddle cannot move, right? So saddle movement is restricted, but here this tool moves based on the reciprocating movement or the provision provided on the saddle. That means this tool can move only in this much of direction. So the tool travel is limited in the capstan lathe, whereas in a hexagonal turret, the tool travel available is comparatively more than the available in the capstan lathe. So I hope you got the clarity what this sentence wants to mean in this particular experiment. So here again, saddle movement is restricted in the capstan lathe, right? And due to that, the movement of the tool is also limited due to the movement of the ram. Whereas in the turret lathe, saddle movement is possible, and due to which the longitudinal direction movement can be easily given. That means entire movement can be achieved using this turret lathe. Now in capstan lathe, for indexing turret tool head, the handwheel of the ram is reversed and the turret tool indexed automatically. Means in capstan lathe, turret tool movement is automatic. Whereas in the turret lathe, the turret tool head movement is rotated. It is mostly rotated manually after releasing the clamping lever. That means in turret lathe, movement of the tool or the rotation of the tool as per requirement, that needs to be done manually. Whereas in the case of capstan lathe, it can be done automatically using the turret indexing mechanism. The next is, we have seen this clearly, right? So capstan lathe used for shorter workpiece because of the limited ram movement. As the ram movement is limited, that means the workpiece which we can machine, that are also limited. Now, whereas in the case of the turret lathe, the movement is possible on the entire lathe machine, and that's why the longer workpiece can easily be machined on the turret lathe. So if we say in the form of the dimension, these capstan lathes are mostly used to machine the workpiece having the approximate diameter near about the 60 mm. Whereas the turret lathe is capable of machining the workpieces which have the diameter up to 120 mm. So these are some of the advantages, limitation of the capstan and turret lathe, and from these you can easily give the comparison of these two particular lathe. So I hope you got the clarity about the major difference between the capstan and turret lathe and how they differ from the original standard lathe. And what are the major difference between this capstan and turret lathe, considering the construction also, parts also, and the movement also, that we have seen clearly. Now we will understand in detail the turret indexing mechanism. Now as we have seen in the case of the capstan lathe, the turret tool head can move the tool automatically based on the requirement. So how this tool can be moved automatically, and this movement can be achieved by using this turret indexing mechanism. So the basic 2D geometry of this turret indexing mechanism is shown over here. Now, as you can see over here, first let us have the introduction about the different parts available in this turret indexing mechanism. So this first hexagonal section, it is known as the hexagonal turret, right? So it is the part of the turret. Then this internal rotary section which is having these slots, it is known as the index plate. Now the third one, internal section available which provides the connection between the rod given over here and the internal portion. This portion third is nothing but the bevel gear attachment. Now this section shown over here having the curved teeth, this particular section is known as the ratchet. So this fourth one is nothing but the indexing ratchet. Now the internal section which is connected to this ratchet also, and the another parts available in the outer direction also. So this ratchet is connected to the internal section, and this internal section nothing but the turret spindle, and this turret spindle is connected to the headstock spindle. Now this sixth one, with this outer gearing attachment, this rod is connected by particular arrangement, and that is nothing but the beveled pinion. As this one is the bevel gear, so motion is transmitted by using the bevel pinion. Now the seventh one, as it is shown over here, which provides the connection between this plunger, its movement, and it provides the connection to the ratchet. So this is section 7 is known as the indexing pole. This pole is useful to provide the connection with the ratchet and the plunger. Now these 8 indicated over here, these are the screw stop rods to provide the movement or stopping connections. Now ninth one, this is the lathe bed over which this entire setup is supported, right? The 10th one, that is the plunger actuating arm. That means, now what is this plunger actuating arm, that we will discuss in later. First of all, as you can see the section over here, this particular section, this section is nothing but the plunger, and the pin shown over here, this is known as the plunger pin, and this plunger is connected by using the one spring attachment, and it is known as the plunger spring. So here the 10th number that indicates the plunger actuating arm, that means this is connected to this plunger pin, and this plunger pin provides the movement to this particular plunger. So these are the different parts available in the turret indexing mechanism, and how this turret indexing mechanism will work, that we will understand. So now first, as you can understand, let us understand this particular section. Okay, this section is the plunger, and this plunger can move in upward and downward direction. So this plunger is fixed in the slots available in these index plates, and this index plate is through this bevel gear connected to this ratchet, and this ratchet is connected to the turret spindle, and this turret spindle is connected to the headstock spindle during entire machining operation. So now when this plunger actuating arm, this particular portion when operates, suppose when it moves the plunger in upward direction, then what happens, this plunger gets out from this slot, and as this entire mechanism is connected to the headstock spindle through this turret spindle, it starts rotating. So as this plunger moves in the outward direction, what happens, this particular ratchet or this turret spindle rotates. As this turret spindle rotates, outer ratchet is also rotates. This ratchet rotation is helpful to achieve the required tool. Right. Now in another way, let us see. As you can see over here, this is 7th section, that is the indexing pole. That means how much this index plate will rotate, that is managed by this indexing pole mechanism. So when this plunger moves in upward direction, as this rotation takes place with the arrangement of this particular 7th part, that is the indexing pole, this ratchet and pole mechanism gets connected. And as this pole is nothing but one type of the rod which connects to the ratchet, which provides the movement to this entire mechanism. So as this plate starts rotating, when it moves in forward direction and these slots comes over here, again due to the cam operation, cam and follower operation that you will study in the com subject, that cam operates accordingly and this plunger moves back in the downward direction. As this plunger moves back in the downward direction, what happens? The tool automatically gets rotated by one slot. And all the tools are attached in these different slots which are connected in the outer or the upward section of the lathe machine. So again, let me explain to you. First, when this plunger moves in upward direction, what happens? With the help of this turret spindle and this ratchet and pole mechanism, it starts rotating. When it gets rotated and how much it rotates, that is controlled by this ratchet and pole system. So when it rotates, it moves in the forward direction. When this slot comes, the arrangement is such that when this particular slot moves to the position of the first available slot, the cam operator available over here, this cam operator moves the plunger in the downward direction and it gets fixed into the slot. And as it gets fit, we can see that the tool is rotated by one index. And the requirement of each and every tool in which particular sequence we need to do the machining, according to that each and every tool are arranged in the turret index head. So based on the machining required, when after the machining, when the tool moves back to its origin position, at that time this entire tool changing process occurs. And when this tool changing process occurs, when further processing starts, at that time already the tool is changed and the further processing we can continue easily. So this entire process is nothing but the direct indexing mechanism by which we are moving the cutting tool automatically based on the requirement. So I hope you got the clarity about this direct indexing mechanism and how it is useful. So in this lecture, we have discussed about the capstan lathe, turret lathe, its basic difference and the direct indexing mechanism. So looking forward to see you all in our next lecture. Up to then, thank you.